So let's learn a little bit about what makes something an acid or a base. So we're going to look at two different definitions for acids and bases. And the first one is called the Arrhenius model, or the Arrhenius acid or base model. And this is the most traditional model of an acid or base. In the Arrhenius model, an acid is a compound that donates H+ ions or hydrogen ions into solution. So when you have an acid in solution, it's going to break apart and it's going to donate H+ ions or hydrogen ions into the solution. So two examples would be hydrochloric acid. So when that dissociates, it donates an H+ and a chlorine ion. And the other one would be hydrofluoric acid, which is HF, and when that dissociates, it donates its hydrogen ion, and then it also has the fluorine ion. So that's an acid according to the Arrhenius model. A base, according to the Arrhenius model, is a compound that donates hydroxide ions, or OH ions, into solution. So two examples of Arrhenius bases are lithium hydroxide, which when it dissociates would turn into lithium ion and hydroxide ion, so there's the hydroxide. And the other example would be barium hydroxide. When it dissociates, it donates its barium ion, and then in this case, two hydroxides. But the bases donate the hydroxides, the acids donate the hydrogen ions. So that's how you can tell the difference between an acid and a base according to the Arrhenius model. The other model that we're going to look at is called the Bronsted-Lowry model, and this is the most versatile model of acids and bases. In this case, an acid is still a compound that donates hydrogen ions to solution. So we're still donating the H+ if it's an acid. However, the difference comes when you look at the bases. Bases, according to Bronsted-Lowry, are compounds that accept hydrogen ions from the solution. So we're looking at what compounds are giving the hydrogen ions and what compounds are accepting hydrogen ions. So we're not looking at hydroxide at all according to Bronsted-Lowry. We're looking at, is a hydroxide being donated or is a hydroxide being accepted? And in this case, we're looking at a relationship between some compound and water. So the one that we're going to use in our example is ammonia. So NH3 reacting with water, and it's going to turn into the ammonium ion, which is NH4+, and the hydroxide. So let's go through this and label what is our acid and what is our base. Well, in order for NH3 to turn into NH4+, the NH3 needed to accept an H+, and it's actually going to get it from the water. That if it's accepting a hydrogen, that means it's going to be the base. And where did that hydrogen come from? Well, that hydrogen came from our water. That makes our water, since it donated the H+, that makes this the acid. If we look and go the other way, our NH4+ would be the one to donate the hydrogen ion to get back to NH3, so this would also be an acid. And our OH- to get back to our water would have to accept a hydrogen ion, which makes it a base. So we can also look at these. You'll see them frequently called conjugate acids and conjugate bases. So if our NH3 was our base at the beginning, that means at the end it's going to act like an acid. Whereas our water donated the hydrogen, so it acted as an acid at the beginning. What it ends with is a compound that's going to act as a base. So they go in pairs. So what's starting as a base then it turns into an acid, and so that would be called its conjugate acid. And what originally started and acted as an acid would form what's called the conjugate base. So in this solution, we have two acids and we have two bases, or two compounds that are acting as acids and two compounds that can act as bases. So let's start by looking at what is pH. pH stands for potential hydrogen. So it's a measure of the amount of the hydrogen ion concentration in solution. So our pH tells us how much hydrogen ion is in solution, what's the concentration of it. And it determines whether the solution is acidic or basic. So we have what's called a pH scale. Now we've probably seen this before. It's a scale that ranges from 0 to 14. 7 in the middle is neutral. Our strong acids have a pH towards the 0 end of our scale, and our strong bases have a pH towards the 14 end of our scale, the high end. Weak acids tend to have a pH closer towards 7, closer towards neutral, and weak bases also have a pH closer towards neutral, but on the basic side. So that's what our pH scale tells us, how acidic or basic is our solution.